Hey everyone. So this little experiment here shows a couple of things that I really love about the internet. So first off, you were not afraid to enter my small website. You are not afraid that it will steal your private information, that it will take a lot of space on your disk, that it will crash your operating system, or take multiple steps to run it and see it working. Secondly, it just magically worked on, let's see how many devices. All right, 57 devices across 8 different vendors, 6 OSs, multiple screen sizes. But web is also quite powerful. 66% of people here have access to, devices here give access to camera and mic to web apps. 80% gives access to geolocation. 66% again gives access to peer-to-peer connections, and there are many, many more APIs available. This mix of security, ease of access, powerfulness, allowed web to conquer the desktop. And today, even apps that are running outside the browser, like Slack, Steam, iTunes, are still using web technologies inside. Now, if we want this success to repeat on mobile, we'll have to fill a couple of gaps in web platform. Today, I will talk about 3 of them. First one is ability to work offline. Second one is push messages. And the third one is background synchronization. Thankfully, all 3 of these technologies are covered by the same thing, which is, of course, service worker. And what's amazing is that 66% of the devices here already support it. So cool, let's talk about service worker. My name is Konrad Dzwinel, and I work for a company called Brainly. It's basically a Q&A platform, very similar to Stack Overflow in many ways, but it's targeted to kids. Kids go there to help each other with school material, to answer their questions about homework, etc. And we are available all around the world. In Ukraine, Russia, and Kazakhstan, we are known as znania.com. Besides that, I'm also a Google developer expert for web technologies. I contribute small pieces of code and a lot of bug reports to Chrome DevTools. I also run a couple of my own open source projects. OK, so back to the service worker. As Jakub today already told you on the previous session about progressive web apps, service worker is basically a programmable proxy, so a script that sits between your page or your web app and the network. It gets notified about all requests made by your page. It can pass them to the network and read the responses that are coming back from the network, and of course, pass them back to your page. In the process, it can modify these requests and responses, cache them, and many other things. So since this is intermediate session, we'll jump right into code and see how you can register a service worker. I'll just bump the size a bit. It doesn't work. I can make it smaller if you want, but nope. OK, we'll have to deal with this. So if you want to register service worker for your web app or web page, because service workers are not only web app thing, they are web thing. You have to call navigator, service worker, and register, and provide a script that will be your service worker. We'll talk about the script a bit later. And this method returns a promise, as many service worker-related APIs do. So you will catch a message. You will get informed if registration was OK or when it failed. When it's OK, you will get back a service worker registration interface that we'll cover later on. And if this method of registration looks too complicated for you, there is another one coming soon. It's more declarative, and it's being currently tested in Chrome. And it's just a link in your head of your website. OK, so if we want to write our first worker.js script, we have to learn about a couple of smaller additions to the web platform. First one is URL object. It's super simple, but also very handy. It's you just create an URL object and give it a string representing an URL, and it will parse it for you and give you access to parts of this URL, so no more regexes. You have access to host name, to protocol, to path name, etc. We'll use it later on. Second thing is Fetch API. Who here already used Fetch API? Good, good, good. Not as much as I would love to see, but already a couple of people are using it, which is great. So Fetch API is replacing the god-awful XML HTTP request, finally. It's super simple. You just call fetch method and give it a URL or URL object that we just covered, and it will fetch it for you. So you get response object back. Response object gives you access to response headers, of course, body of the response, but also status message. So you can play with it. If something fails, you can, of course, catch an error. But this is only GET. If you want to do something more sophisticated than a simple HTTP GET, you will have to construct a request object. Request object is also super simple. It just takes an URL, but also takes some custom parameters, like, for example, method, headers, and a body of the message that you want to send. And then such an object, you just give it to fetch, and it does its job as above. Finally, there is Cache API that I would like to talk with you about. Cache API allows you to store files in your file system for later use. It's very much the same as the browser cache, but this one you have full control over. So in order to write something to the cache, you have to first open it. So on the global caches object, you call open function. And here I'm providing a name for the cache I want to open. And the reason is you can have multiple caches for different things. When cache object is returned, you can call a put method on it, which takes request object and response object, the objects that we just covered in the previous slide talking about fetch. But to get request object and response object, you have to do fetch first, which might be cumbersome. So good folks at W3C specified also the add function, which just takes an URL and does all the fetching in the background. There is also a super handy add all method, which takes a lot of URLs that should be cached in this cache. Finally, if we want to get something back from the cache, we have to call match method and provide an URL object or request, and cache will hopefully return some result. That's it. That's also super simple. Now we have everything to build our first worker.js script. So let's go through this simple scenario. Let's say you have a blog, and you want all articles that user previously visited to be cached. So whenever a page requests some resource, service worker checks if this request is for an article. It can go to cache and see if this article is already cached. If it is, just return it back to page. If it's not, go to the network and let's assume it downloads correctly. It will send it back to page, but also put it into cache for later use. So let's try to implement this. So here we are in our worker.js script. And in worker.js script, you don't have access to DOM. You don't have access to any synchronous APIs like local storage or session storage. But what you can do is listen for some specific events. Here, we are listening for a fetch event, which is fired whenever your web app or web page requests something from the internet. So with the event object that we are getting here, inside this object, we have a request object. And from this request object, we can pull an URL. Then we can parse it using URL object and see if this is an article. If it's not, the script will just finish, and the request will be made normally as if service worker was not there. But if it is an article, we want to say back to the browser, hey, we will handle this event ourselves. Don't do a normal request. So first off, as you remember, we want to go to the cache. So here we are checking if our article is in cache, and if it is, we are returning it. If it's not, we are using fetch API to get it from the internet, as usual. If it succeeds, we first put it in the cache, and then return it to the page. Some of you probably can see that I'm doing something strange here, and I'm cloning the response. There is fresh item.clone. And the reason is, these responses are streams, and you can read a stream only once. So if we want to put the same object in the cache, but also return it, so use it twice, we have to clone it. That's it. It's a performance thing, I'm told. OK, but this was only one scenario that we covered. Let's talk what else can we do for different types of resources. And since my company is migrating the whole service to HTTPS, we are starting to think about implementing service worker. And we already started playing on the test environment. So we have a question page. This page changes a lot because question can be edited, answers can be added, there can be new comments can be removed. So normally, we would like to try to get the fresh version from the internet. But if we fail, we would like, for example, because user is offline, we would like to serve or show the old version. So this strategy is called network falling back to cache. Page requests something. Service worker checks if this is a queue page. And if it is, it goes to the network, tries to fetch it. If it fails, because user is, let's say, offline, it goes to cache and returns it back from cache. Another type of resource. Under categories, we have this small stats showing how many people are online and looking at this specific category. These stats are totally not important. They are just, I don't know, just an addition for fun. So we don't care if these are accurate. So here, we could use revalidating caches strategy. The way it works is page requests stats, service worker gets them from cache, and immediately returns them to the page. So it can display them immediately. But after that, in the background, it goes to the network and updates the cache, so that the next time user wants to see stats, he will be given data that is more fresh. OK, last example, avatars. So for users that provided avatar, we show an image. But for users who didn't, we show just gray generic image. So what we can do here is use a technique called generic fallback. And it works like this. Page requests an avatar. Service worker checks if it has it in cache. If it doesn't, it tries to fetch it from the network. If it doesn't get it from there, it goes to cache and gets the generic gray avatar and returns it back. This way, we'll always return some kind of image to the page, and page doesn't have to do any error checking on images if it loaded or not. It will still look good. Worst case scenario, all avatars will be gray. And there are like many fantastic ideas what you can do with Service Worker. Couple of ideas that I especially like is returning different image based on user network capabilities, because we have this API now that allows us to check what connection user is on, so for example, 2G. And based on this, we can fetch a smaller image to make the app work faster. The last one is also pretty good. You can use Service Worker, since it's a proxy. You can use it for mocking requests. Let's say backend team is moving slowly, and you want to work on the front end. You just mock everything in the Service Worker, all responses from the API, and you can work on your stuff. OK, we have 3 features to cover, so we have to move fast. Next is push. So push is probably one of a couple of reasons why hybrid apps were created in the first place. It was always missing from the web. And now, with power of Service Worker, we finally have it. Jakub mentioned briefly manifest.json file that you can include to your website or web app. It has some additional metadata like icons, name, short name, etc. That you can put there. And if you want push messages to work, you have to provide Google Cloud Messaging sender ID. Right now, Chrome is only supporting Google Cloud Messaging, but of course, this is web, so this will be open for all providers later on. This is basically idea of the project that will be our backend, and will send actual notifications, push notifications. Yeah. So in the Service Worker, like on the page, when we first register a Service Worker, we get this Service Worker registration interface. It allows us to access Push Manager, which in turn allows us to register for push messages. You can see there that we have some setting, user visibility only sets to true. And that's because we are basically telling Chrome that we will use push messages for showing notifications. And as funny as it may sound, you have to put it there, and you have to set it to true, because false is not supported right now. This is because we don't want push messages to be used for other stuff than notifications right now. If registration goes OK, we'll get some endpoint information, and endpoint is what you want to send to your backend. Backend will use it to send messages to this specific device. OK, so what happens when a push message comes? When push message comes, your website doesn't have to be on. Chrome will wake up Service Worker and pass event, which contains some information regarding this push message. And what you can do is show a notification right away. But actually, this is a simplified example, and you shouldn't do that. Twitter does that, and this is super frustrating, because they show you a notification, and if you go offline and try to click it, they will just show you an error message that they cannot load the content. What you should do instead is, when push message comes, go to the network, grab everything you need to show content for this notification, put it in the cache, and only then show the notification. This way, when user goes offline, he will still be able to click notification and see some actual content. OK, and finally, we have background synchronization. Background synchronization solves one specific problem. I guess we've all been in this situation. You have some form, you click send, the loader appears, but it's just loading and loading, and you don't know what to do because you're afraid to reload the page because you may lose the data that you just put. So this is kind of frustrating, and it's frustrating on desktop and mobile, but on desktop, at least you can change tabs and do something else, watch cats. But on mobile, you're basically grounded. You have to look at the spinner. So in order to solve this problem, we have background sync. And whenever you want to send some data, instead of doing fetch or AJAX request, you have to request a sync event. Sync event will then wake up service worker if it's sleeping, and it will do it only if the connection is back. So if user is right now connected, it will just do it immediately. If user is not connected, it will do it when user is back online. And service worker will do all the hard stuff of sending and synchronizing. And that's it. So the code looks like this. We first register our service worker. So to do that, we again need access to service worker registration interface. And we get this object when we first register service worker. But when someone clicks submit, we have already registered service worker. So we have to find another way to get to this object. We can, of course, cache it and keep it in some variable. But also, we can just rely on service worker ready promise, which will return it as soon as it's available. And then on service worker registration, we have access to sync, where we just call register and provide the name of the sync, because we can have multiple syncs doing different things. Then in the service worker, we get a sync event, we get the name that we provided, and we tell the browser to wait until we finish and do some operation, like sending data. If we fail, browser will schedule another event for us. So basically, we are covered. The message will be sent later, sooner or later. OK, and this is a bonus round. DevTools, because DevTools also changed so that you can have a nice workflow with service worker, and they changed quite a lot. Now we have something called application tab. I don't know if you've seen it, but it's already unstable. And in application tab, you have service worker category, where you can see all the service worker running on given site, because there can be more than one, which is, well, I wouldn't recommend having more than one. But you can, sure. And from here, you can do a couple of things. You can update service worker. You can fake a push message, fake a sync message that we just covered. You can quickly go offline to see how the website works offline. And also, you can just remove it. Below, we have cache storage category. It's the category that it shows everything that we stored through the cache API. So these are the files that were stored. And from here, we can just delete them if we want. If you'd like to debug service worker script, it's in the obvious place, which is Sources tab. And you can just open it up as any other script, put breakpoints, and see what's going on. Similarly, in the console. In the console, only thing that you have to do to talk with service worker instead of your page is to switch the context. And you do it in the console interface. So DevTools are ready for service worker, but is service worker ready for production? And in my opinion, it is. It already ships in Chrome and Firefox and in Opera. It's in development in Edge for a couple of months now, and Safari is considering it. But they also included it in their 5-year plan, which hopefully doesn't mean that they will implement it in 5 years. Well, we'll see. But in my opinion, it's ready, and I hope that I inspired you to look at it and play with it. But if you have any questions, I will be happy to answer. Thank you.
Okay, so raise your hands, and I'll go to you. Don't scratch in your head, because I think you want to ask something. No questions? Aha. Just correct pronouncing. Questions?
Thank you. It was very awesome.
Thank you.
Can you tell about performance on mobile application when we try to cache everything? What will be how it works on mobile phones?
Yeah.
Thank you.
Yeah, that's actually a really good question, because we have this cache API where we can put a lot of files, and we can, if we want, we can put a like 300 megabyte video there. But this cache is not persistent. It means that if your device will run out of the space, Chrome will start clearing space up, and it might remove stuff that you have in your cache API. There are already some specs for API, like similar to Cache API, that allows you to store files permanently. But this, of course, will require user interaction. It will ask user if he or she allows that. So there is that. I hope I answered your question.
Hello, my name is Roman. I have a question. So, would you recommend this service workers for production use? I mean, how do you solve the problem with Safari compatibility in your website? For example, a lot of market share is iPhones, Macs.
Sure.
So how does it work on that platform?
Yeah, that's also a very good question. So the idea of progressive web apps is to be progressive, to only use what the browser allows us, only what the browser gives us. So we can easily check if service worker is supported on given browser and use it or not. So for Safari, basically, will be like normal web app without offline support. But for the other browsers that support it, we will be working offline, which will hopefully put some pressure on Safari to actually implement it if many people start doing this.
Thank you.
Thank you.
Okay. Any other questions? No question. I see.
Question from Android guy.
Does it mean you need to have like two different implementations, for example, for sending the command to the server, just to have a support both for the browsers that are supporting service worker and for Safari, for example? And how do you handle that? How does it scale?
Yeah, so we don't have two different implementations. We actually do an if that checks if that given feature exists. If it does not, we just don't care and proceed normally. If it does, only then we give certain offline capabilities. So it's not like we have to maintain two different implementations for two different browsers.